All right, we're back. It's still Monday, the fourth day in August of 2025, and over here, what I've long been promising, the quantum of gravity. All right, you know that this will require at least 1,276 pages of explanation if it's anything like Geometrodynamics, the title of the Kip Thorne, John Archibald Wheeler, and Edward Missner book, which is now legendary as the Black Bible of Gravity. But in this single diagram, as I promised, you get that entire book condensed into one visual image. Now, there is an aspect of this image over here. This you'll see is a little blue ball with a line, a horizontal line, indicating negative Coulomb charge. You can disregard that except for the geometry. I do geometry. That's the whole nature of my YouTube platform. 1,070 videos, most of which are on geometry and the mathematics underlying geometry. Mathematics is a tool of geometry. You won't hear that said very often, perhaps never. I've never heard it said, but it is the truth. That is what I deal with, is truth, because that's what science deals with, is truth. It's just that we have a very rigorous method of going about to acquire truth, whereby we require proofs for anything that we say. Quite difficult. But Newton got us going. Euclid really got it started with his axiomatic approach, which is, I fully agree, was a major breakthrough 2,500 years ago. Well, we still use that method, so do I. That's science. Strict science. Science, however, is huge. I always like to give a little bracketing information, but this won't go on very long. In fact, let's curtail that and get to the point. Where in that diagram is the quantum of gravity, if indeed that is what is portrayed? Well, it's that big red dot. That is a proton. And it's very well portrayed as what it is. It's the simplest thing we've ever discovered. It took a long time to discover the proton. It was in the 1920s that the proton was finally realized through the use of mathematics and technological instrumentation to drill down that far into the heart of the atom to discern that there is a center to the atom. It's a little bit complex, and you would know that if you have seen the periodic table, because an atom does not just contain one proton unless it's hydrogen, and this shows simplex hydrogen. The reason why we have to add the word simplex is because any element may have isotopes, I believe they all do, which refers to the number of neutrons, which do not affect the Coulomb force structure, because a neutron, as per the name, has no charge. So that's electrodynamics, and this shows electrodynamics in its simplest form, a plus at the center and a minus that is on the circumference of a force field. And it is a force, despite what Wheeler, Missner, and Thorne say. They say it is not a force. And about half of all physicists say that gravity is not a force. You may know why, but it helps to just state the obvious at the outset of a scientific presentation, so we all have the same framework in mind. Is gravity a force? Yes, it of course is a force. Sorry, that sounds like the theme to Mr. Ed. A force is a force, of course, of course. All right. But why would anybody say that gravity is not a force? It's because of the curvature of space-time. Dr. Sabine Hassenfelder, a very respectable presenter of muckraking physics, which I respect because somebody has to rake the muck somewhere. She's written a whole book called Lost in Math, which is now a somewhat semi-underground classic because, of course, the mathematicians don't like that. And the mathematicians can suppress anything they want. Except out on YouTube, Dr. Sabine Hassenfelder is slipped through the cracks and she presents her thesis, which is the mathematicians are fucking out of their minds. Although she herself is a mathematician and makes her living doing just that. She's attempting to reformulate quantum dynamics from the experimental side, which is a dead end, and she probably knows it, but as long as she's getting a paycheck, I say, go Sabina, way to go, go girl. So she's doing the right thing, but it's really a hopeless task. It's what is called a, let's see, how does Cervantes put that? A quixotic venture, which means you're not going to get anywhere. But you will have a fun time if you play your cards right, getting through this labyrinth, which today is called mathematics. So is gravity a force? Well, let's see. We have two choices because there are exactly two models. And this is a modeling approach. If you accept as the correct model Einsteinian spacetime, you do know that he used mathematics to curve flat space. The flat space is Minkowskian space, as I discussed in a recent video, and that is a 4D projection. And this is a 2D projection of a 3D phenomenon called the atom. The simplest of all the atoms is simplex hydrogen, which you see in this very simple diagram. So what do you see there? In a presentation of science, you have to state the obvious first in order to get to the cutting edge where you want to broach a new statement of some kind. I want you to see the lab cat. There she is. Look at that. She's conked out because of the heat. I'm sweating, but I'm happy. She's happy too because she's asleep. There we go. All right. So that is the simplest atom. Now, the first thing I want to mention is that every proton in the universe is exactly the same. It's also a quantity, although a quantity of what is presently being discussed at the cutting edge of science with the aid of hadron colliders, which are formerly called cyclotrons, because you accelerate a proton in order to induce it to crash into a relativistically stable or inertially framed proton, whereby there's an explosion into a bubble chamber, is the standard way of doing that. Why is that being done underground in Switzerland and in other places? It's to find out what's inside, because there's something inside that big red dot. That has been explored down to a mathematically formulable system composed of 3 parts, and that 3 is significant. It was discovered by Gell-Mann using pure mathematics, which then has to be explained geometrically. That has not been done yet, and that's the cutting edge of science and subatomic particle physics now, certainly at the protonic level. We're also, of course, still exploring the nature of the electron. That's that little blue dot. So this is the simplest system in the universe. What's inside the red dot and what comprises the blue dot is partially called quantum mechanics and partially called currently the standard model of particle physics. So those are areas that are necessarily complex and very likely complicated. I think you would realize quickly, if you haven't already, it's both. So to begin at the beginning, I will state hypothetically, you're not supposed to agree with what I say. You're supposed to listen to see if I can prove what I say. But in order to prove something that you say, you have to say it first. And because you haven't proved it yet, it's going to sound a little dicey. But I don't think that I'm going too far out on a limb, except perhaps in the nomenclature, which I will define. That is a quantum thing. It is a quantum. That's a proper statement if you define the word quantum in context. What I mean by quantum is truly the original definition, is that it is a unit, all of which units are identical. And we've only discovered one of those. The photon cannot be said to be like all other photons because they have different frequencies. You could state that in other ways. But photons are not all alike in the sense of being a quantum. The electron, likewise, because electrons are also quanta of energy. That is, any electron is a quantum of energy, but the quantum value varies. In the proton, it's always the same. Every proton in the universe is exactly the same, which is quite a profound statement, I should have to say. So that's our first statement leading up to the proof that that is a quantum of gravity. Now, we would have to at least make some statement of what is meant by gravity. I will state the obvious first, per my approach, which is the Polya approach. Very famous problem-solving approach. So that is, in my hypothetical statement, a quantum of gravity, which means a unit. And in fact, in the proper use of the word quantum, it is an indivisible unit. An indivisible unit of what? Here is a key term which I really want you to absorb, to grok on, to use Heinlein's term. Centripetal. Centripetal. Centra means center. Petal essentially has to do with force. And there are two forces you can state logically. There are two spherical forces. They're not lateral forces. They're not Newtonian forces. They're non-Euclidean forces. And these are the two forces that you could say might be said to govern the universe. Because there are only two of these. One is centripetal, which means pulling in. That's gravity. That's not the only centripetal force that has a word attached. Gravity is a centripetal force. Try to think of another one if you can. How about two magnets going toward each other because they're oriented minus to plus? Would that be centripetal force? It could be. I would say that it is, but I'm just putting that out there so that you know that there are different manifestations of centripetal force. But those are the only two that I can think of. Magnetism, when it's so oriented in two magnets,
or a magnet and a ferromagnetic
material, the ferromagnetic material will go towards the magnet no matter what. But if they're two magnets, they might repel. If they're oriented plus to plus, they will repel. That's the other force. That's not centripetal because it's going out from what's called a barycenter or a common center. The center is between the two magnets and they're being repelled because their force fields overlap at a balance region. And so the two force fields repel. Now, that is a proton, and it exhibits centripetal force with respect to the electron. What about two protons? Their Coulomb force repels. So two protons at a distance further than, I'll just say, than 2 femtometers. Things change when they get closer. But when two protons are sufficiently far from each other, they repel. And it can be shown on an asymptotic curve, mathematically correct, that they repel forever. That if there were only two protons in the universe, they would repel infinitely. But they would slow down as they're being repelled. That's called an asymptotic relationship. So that's the nature of two protons, according to the Coulomb force, which has a couple of other names. It's electrostatic force. It was basically investigated by a man named Coulomb around the turn of the 19th to the 20th century. Now, as you may be aware, if two protons get close enough, they no longer repel. Well, that's quite a mystery. But it is well known, it's been proven. Because if two protons get close enough, they will bind with a release of energy. That's called fusion. The force that binds them at that extreme close range is called the strong force. Although, according to the standard model of particle physics, they've changed the definition according to their mathematical and modeling needs. We disregard that because they're quite specialized. They believe they're pursuing the right course, and I don't argue with that. But it has nothing to do with reality until they can prove it, which they can't and won't. So their model is incorrect according to the way I approach things, but it doesn't matter, so I don't emphasize that. I simply wish to exclude their psychotic approach, which is prejudicial. That's too bad. That's how science works. Whether I'm right or wrong, I'm using the right approach. So, the strong force is exactly what I just said, and not at all what they say it is. They use something called chromodynamics, which has to do with the coloring and flavoring of the quarks, which have not been isolated and have not, strictly speaking, been discovered. But mathematically, you could say there's a quark trinarity, which I consider to be incredibly profound, but I will show you what it means. Because in order to get the meaning, you have to know the geometry of the quark triad. They can see it mathematically, though, and I believe they've proven that there is some substance to the quark trinarity. The number 3 is most peculiar at this inner level, but that's not the topic at this moment. The topic is gravity. It is a centripetal force, and it has to be a force. Otherwise, the two protons could not bind. They're binding with centripetal force. That's the definition of how they bind. It's the overcoming of their natural electrostatic relationship, whereby at sufficient range they repel. But if one of them has relative velocity and can close the distance past a Lagrangian diameter, see, it's not a Lagrangian point. It's a Lagrangian surface between two force fields. What that means is there's a balance, a highly unstable balance region, which is the intersection of two spherical force fields. There is a neutral zone right at the barycenter between them, which has a spherical projection because they're two spheres. So, to put the gobbledygook into common parlance, what that means is when the two protons have sufficient relative velocity to close the distance beyond the Lagrangian range, they overcome the repulsive force, which then turns to attractive force, and then you would think that they would collide, but they don't, because they're stopped by a mutual repulsive force once again. So it starts out repulsive, then it becomes attractive, and then it stabilizes into helium in this case. So that's very simple, and that's well known. That is not hypothetical. That has been proved. The question now is, how do you explain that geometrically? Without a geometry, there's no explanation. You can't understand anything directly from mathematics. It must be translated to what mathematics is intended to support, which is a geometric construction, and so they're related. Mathematics and geometry are directly related. So it's very important to use the right mathematics. Which mathematics are we using? Your natural response, I would assume, is the way you and I were taught, is there is only one mathematics. That's extremely naive, because numbers are as abstract as you can get. They're representations of something physical, you hope. So, to go back to our topic, to complete this definition of the quantum of gravity, you are looking at it because it's a quantum force. That makes it a particle, because in order to have a quantum force, you have to have a quantum center. Otherwise, there's no sphere. You can see that this is a sphere, although of course it's a projection down to 2D so we can put it on a piece of paper. But those are spheres, and everything in that diagram, except for the two symbols, are spherical. Everything is spherical. There is a linear component, which is all that mathematics is allowed to use, called the radius of the sphere. And if you try to extend linear mathematics to the circumference, where there is a circle, you fail, because that's not linear mathematics. It's not linear geometry. It's spherical geometry, which I discovered. Now you may scoff at that. We've always known about the sphere, and that the sphere has a geometry. Yes, that is all true. But what you're leaving out is, there's never been a mathematics of the sphere. There's never been a mathematics of the circle. And the Greeks discovered that quite to their chagrin, because the circumference of a linear radialized circle, for instance, radius 1, you know what that produces for what would be the linearization of the surface, which in the case of the circle is 2 pi. And 2 pi occurs in every equation. Every equation. 2 pi. That has a new name, although Euler is the one who devised the idea that you could take out the 2 and just call it by a new symbolic name, which he suggested should be E, and he was not naming it after himself. It was just the next letter that he thought was available for 2 pi. We do not accept that. It's just consensually discarded because mathematics has no feedback system. It cannot correct itself at any level. Mathematics, alas though, it's not God because it's not real mathematics. It's derivative mathematics, and you can see that because that circle is real, but the radius is a derivative quantity. And you can see that instantly because the surface value of a unit circle is 6.28 ... The ... means it's not a number. It's an approximation, which is not a number. And that is well known but well denied. But it is a fact. I'm using language in a way that I consider to be appropriate to say that it's not a number, but you can write it as a number, can't you? 6.28 is a number. Yes, if you could write 6.28, it would be a number. But you can't write it as 6.28. There's a ... And that ... means it's interminable. And if it's interminable, it's not a quantity. You can say so if you want to deceive yourself, and that's what linear mathematicians do, which is why I say, one reason I say that they're psychotic. They already know they're saddled with 0, which is an infinity. And that's well known in my world, I'll say, but science is consensual. So I have to broadcast this if I'm a real scientist. Come hell or high water, at whatever risk. Galileo did. So did Einstein. Einstein was ridiculed for general relativity. At first. It wasn't long before everybody reversed gear and jumped on the bandwagon, because that explains the Big Bang. They're out of their minds, and that proves it. That's a solid proof. You came up with an anti-physical model that now you say is true just because you say so. Because your numbers tell you, but you're not using numbers. You're using fantasy. This is not fantasy. That's geometry. So what does it say? It says that there is a force center with a radius. And that electron that's, we'll just say for the time being, orbiting, it's a standing wave around the proton. The electron in this diagram is not that little circle. It's just represented as a little circle because it does follow a circular function. And the electron itself manifests a circular function. The proton manifests a circular function in space. The electron cannot be said to manifest a circular function in space the same way. They're quite different, and this diagram proves just exactly geometrically how different they are. At the force inversion range, which is that circumference, that's on the outside, the electron is being drawn in towards the proton. But you see, the electron will not go inside that radius. That's because it's being repelled by the opposite force. So there's a force balance being shown here between centripetal and centrifugal. Centripetal and centrifugal force is probably the best way to say those two words. Otherwise, they sound alike. Centripetal, centrifugal. Centripetal, centrifugal. Centripetal, centrifugal. I just learned something. I'm going to adopt that convention from now on, assuming I remember, which I believe I will, because this is what I do, is geometry. You're seeing the simplest geometry in the universe right there. That is quantum geometry. At the center is the quantum of gravity. And that single electron is the quantum of energy. And now you see the two quanta that science is searching for. You just found them. And what I said is absolutely provably true mathematically. That's what I'll show you next. We're coming up on a half an hour. I do like to keep these videos brief because of attention span, which we all must deal with. We get tired. And we hope we're not being bored, or we get tired much faster. I hope I haven't bored you. You're looking at the quantum of gravity and the quantum of action. Action exists in a different spherical dimension. There are two dimensions portrayed here. The force field, which is a single line going in all directions spherically, here portrayed circularly. The force at the surface from the inside out is equal at all points. So the mathematical definition of that surface is no longer tau. It's no longer 2 pi. In true mathematics, which is two-component light-speed mathematics, it's actually space-energy mathematics. Not space-time, but space-energy. You're seeing space, the quantum of space, and you're seeing the quantum of energy in exact relationship that's rational. That'll be in the next video presentation. I hope you stay tuned. This will be the most important sequence you've ever witnessed. Keep looking up. We'll be right back. Thank you.